Okay, I've just done a sound check. I know the sound is working. I am so sorry for the video last week. Okay, so I just basically like to do the same learning that we did last week, but this time with sound. So last week's video was practice with abstraction, okay? I'd like to show some of the benefits of using abstraction. Okay, those benefits, as we've discussed, are things like it allows two or more teams that have agreed upon a common contract or interface to work independently, right? We come together, we agree on an interface, and then we go our separate ways and we write code that uses that interface or fulfills that interface, right? So that's one of the benefits of using abstraction or interfaces, right? And also it's very easy to change the implementation of the thing that implements our interface, or include objects that are not in an inheritance relationship in our usage of interfaces. So what I'd like to do today is build a very lightweight app that uses financial accounts, maybe something that we use here at Health Equity. It uses investment accounts, health savings accounts, and reimbursement accounts, okay? And all of these are going to have a common interface for withdrawing funds, let's say, okay? So I'll build, first off, I'll build the interface, and then I will use that interface without implementing any logic in the business logic classes, we'll call them. And this will simulate a team or a couple teams coming together, agreeing on an interface, and then going their separate ways and writing code. Okay, so let's go ahead and create an interface. And we'll call this I make withdrawals. Okay, so let's go ahead and create a method in our interface. All the teams are coming together and agreeing that when we make a withdrawal, we should always return the balance. The method name should be make withdraw, or let's just call it withdraw. And there should be an amount that we should withdraw. Okay, this is our common interface, right? This is our contract that both sides will work towards. Okay, let's create real quick an object or a class. So let's make an object that implements this interface, or a class that implements this interface so we can use it. All right, as we said, we're going to have health savings accounts. Okay. Always have to include the class keyword. All right, Visual Studio is telling me I need to implement this method, so I will do that. Okay. We'll also create the reimbursement account and the investment account. Okay, you can see here that the interface is now defined. The teams, maybe there are 4 teams involved, right? People who are going to write our app, people who are going to build logic for health savings account withdrawals, people who are going to build logic for reimbursement account withdrawals, people who are going to build logic for investment account withdrawals. Okay, so this interface is like the contract. We know that there will be a method called withdraw. It will take in a decimal and it will return a decimal. And this is how our different systems, our different pieces of code will interact, right? So it's an abstract idea. We don't know how it's going to do withdrawals, but we know the name of the operation and how to give it inputs and what outputs to expect, right? So this is a very real world scenario here. Teams will come together and agree on much more complicated interfaces, but they will then go their separate ways and code to the interface. So let's now simulate the app team, okay? The app team over here is going to build an app that uses objects of type I make withdrawals, okay? So I'll pause the recording here for a minute while, well, no, I'll build, because I know some of you code along. Here we go. We'll just give some lovely user messaging here. Okay, we've got the basics of our app here, so we're going to give some user messaging, we're going to read in a key, and then as long as they didn't press X, we will do some stuff, and then we'll keep reading in a key. We'll make sure our app doesn't close without us. Okay, let's write some logic. If we pressed H, we need to do something, right? So what we need is a new variable, and it's going to be of type I make withdrawals. Okay, so you'll remember that anything that implements an interface, you could say is a type of that interface, right? It's how we have an is-a relationship without inheritance. It's really powerful. We'll see why here in a minute. Okay. Good. Okay, so this is how we are going to use our interface here. All we need to do now is make a withdrawal. Let's make sure and ask them how much they want to withdraw. So we'll come up here and okay, here's our withdraw amount. And because I happen to have named the variable exactly the same in all three if blocks, you will see that I can now copy and paste this code into all the blocks. Okay, so even though these are very different accounts, health savings account, reimbursement account, investment account, right? I have a common way to work with them. It's with I make withdrawals, and all of these, even though they're separate types that do not share a common parent, they are all of type I make withdrawals, and so I have a very well-known way to work with them. Okay, so this is a program that doesn't do much right now. Actually, it's not going to throw any exceptions. Let's run it. Oh, that's small. All right. There we go. Okay, so the app team was able to come in here and write this app before the health savings account team, the reimbursement account team, or the investment account team wrote one line of code, okay? That's the beauty of abstractions. We know how or the names of an operation, but we don't really care if it works or how it works, right? We just have the way to work with it. We have the big panel with the big red button, and we can press that button even though that button may not be hooked up to the electronics of our fridge, for example, okay? So one of the benefits of using interfaces, it's a contract. It allows us to come together, decide on how we will work together, and then break apart and write code. So the health savings account team got together and was like, all right, it's time for us to implement our code. So a health savings account has a balance, but it's private. Okay. Health savings accounts happen to be funded at $500. Okay, so every time a health savings account is created, we're funding it at $500. And when we withdraw, we just take out the amount. Okay, so we're going to go balance right, very simple. When a withdraw amount comes in, we're just going to draw down the balance, and then we're going to return the balance, what their current account balance is. Very simple. But reimbursement accounts are not so simple. Reimbursement accounts also have a balance. Okay, reimbursement accounts. They also have a balance. right? But let's say they have a max withdraw amount. Okay, so this max withdraw amount, let's say that the balance, we always fund it at $1,000, but the max withdrawal amount is 20. Okay, so we're going to say that the business logic here is if a claim comes in that is more than $20 and they need to withdraw more than $20, we're only going to charge them $20. All right, conditional operator to say which one of these two we will actually use. Okay, and then we're going to draw down the balance. And then we will return the balance. Okay, investment accounts, every time there's a withdrawal, we also charge a fee. So we need to do the withdrawal amount, and we also need to do the fee amount. As far as funding, $2 fee. There, very fair. We'll make lots of money. All right, so the logic here is fairly different, right? It's still pretty simple, but it's fairly different. So an investment account charges a fee. A reimbursement account will only withdraw 20 or less, and an HSA will withdraw the withdrawal amount. Okay. Okay. Let's try an RA. Okay. Let's try an investment account. Okay, very good. So interfaces facilitated some good development here, right? The app team could go and code their side of the interface, and these business logic teams could go and do the same. All right, so that's one benefit of interfaces. Another benefit is we can slap this interface on to any class, right? We can take a class that's in an inheritance relationship. We can take a class that has multiple interfaces already implemented on it, and we can swap it in. Okay, so let's say that our tiny health savings account company was just bought by Health Equity. So we need to integrate our app with the Health Equity health savings account. Okay, this HSA is a very different beast, right? So at Health Equity, they don't say withdraw, they say draw down. Okay, and it just so happens the rules are exactly the same. Health equity, of course, is more generous. So how in the world can we come in here and make this work, right? I would have to, rather than using an I make withdrawals object, I would have to say var health equity HSA, and now it's drawdown, right? And I no longer have a uniform way to work with accounts. I don't like that. Our app team is very expensive. We don't want them writing code. So rather than implementing a lot of changes into our app team, what we can do is we can take this very different health savings account class and we can slap this interface onto it. All right. And all this needs to do now, oops. Let's make it call drawdown. Okay, now it's time to swap out these two classes. The only change I need to make is swap out the thing that fills type I make withdrawals. And because we implemented the I make withdrawals interface on our health equity HSA class, we have a common way to work with it, right? So I could do anything. I could have the I don't know, checking account, savings account, cash tucked under my mattress, as long as I have this common way to work with those classes, the changes and impact to my app are going to be minimal. All right, well, hopefully this was a beneficial exercise for you to learn how to use abstraction here, and we'll see you next time.